Beneath the scorching sun and endless dunes, hidden for thousands of years, lies a story of brilliance waiting to be told. Picture this: a civilization so advanced, their engineering feats defied the limits of their time, yet their names were lost to the sands of history. Today, we're peeling back those layers of time to uncover the forgotten builders beneath the sand, the unsung architects of the Bronze Age, whose innovations still echo in our modern world. These weren't just laborers stacking stones or digging canals. They were visionaries, problem solvers who harnessed nature's power with tools and techniques that would astonish even today's engineers. How did they achieve so much with so little, and why have their contributions been overlooked for centuries? Think about the last time you marveled at a towering skyscraper or a complex bridge structures that seemed to defy gravity. Now imagine achieving similar wonders without computers, without steel, without even the wheel in some cases. That's exactly what these ancient engineers did. They transformed arid deserts into fertile lands with intricate irrigation systems, built sprawling cities that rivaled modern urban planning, and erected monuments so precise they aligned perfectly with the stars. Their legacy isn't just buried in ruins, it's woven into the very fabric of human progress. Yet, until recently, their stories were whispers in the wind, overshadowed by more famous empires like Egypt or Mesopotamia. This journey isn't just about rediscovering the past, it's about understanding how these forgotten builders shaped the world we live in today. From the water channels that fed their crops to the architectural principles that still inspire engineers, their ingenuity is a testament to human potential. As we dig deeper, you'll see how their solutions to ancient problems mirror the challenges we face now: sustainability, resource management, even city planning. So let's step into their world where every grain of sand holds a clue, and every discovery rewrites what we thought we knew. By the end, you'll see the desert not as a barren wasteland, but as a treasure map leading to the greatest untold story of the Bronze Age. The Bronze Age wasn't just a stepping stone between primitive tools and modern marvels. It was a blazing era of innovation, where societies cracked the code of progress with nothing but raw ingenuity. Take metallurgy, for instance. These ancient engineers didn't just stumble upon bronze, they perfected it through trial and error, blending copper and tin in precise ratios to create a material stronger than anything the world had seen. But here's what's truly mind-blowing. They did this without thermometers, without chemistry textbooks, relying instead on generations of accumulated knowledge passed down like a sacred craft. And it wasn't just about making better weapons or tools. Bronze revolutionized everything from agriculture to art, enabling plows that could till harder soil and intricate sculptures that captured the essence of their beliefs. Now let's talk about the cities they built. While we often picture ancient settlements as chaotic clusters of huts, Bronze Age urban planners defied that stereotype. In places like Mohenjo-Daro, part of the Indus Valley civilization, streets were laid out in precise grids, complete with advanced drainage systems that would put some modern cities to shame. These weren't just practical solutions, they were visionary. They understood the importance of sanitation, of flow, of designing spaces that harmonized with human life. And then there's the mystery of their water management. In arid regions, they engineered elaborate irrigation networks, diverting rivers and storing rainwater with such efficiency that their farms thrived in environments where even today, survival is a challenge. But perhaps most fascinating is how these achievements were interconnected. The same societies that mastered metalworking also pioneered astronomy, using celestial patterns to align their temples with solstices and equinoxes. Their buildings weren't just structures, they were cosmic calendars, stone embodiments of their understanding of the universe. Recent excavations have unearthed tools and blueprints scratch marks on clay tablets that reveal meticulous calculations, proving their methods were anything but guesswork. So why does this matter now? Because their legacy is a reminder that innovation isn't about having the fanciest tools. It's about seeing possibilities where others see limits. Every time we marvel at a modern engineering feat, we're standing on the shoulders of these forgotten giants, whose brilliance was buried but never truly lost. The forgotten builders weren't just anonymous faces in the crowd, they were the backbone of Bronze Age civilization, working in shadows while kings took credit for their genius. Imagine spending your entire life perfecting a craft, knowing your name might never be recorded, yet your work would outlive empires. These were the stonemasons who carved blocks so precisely they fit together without mortar, the metalworkers who turned raw ore into gleaming tools, and the surveyors who mapped cities with nothing but ropes and stars. Archaeology gives us glimpses into their world, fingerprints preserved in clay bricks, tool marks left on temple walls, even ancient payroll tablets showing some were paid in beer or grain. What's striking is how specialized their skills were. At excavation sites across the Mediterranean and Near East, we find evidence of guild-like systems, groups of artisans who guarded their techniques like trade secrets. A potter in Mesopotamia might spend decades mastering the perfect glaze formula, while a Cypriot bronze smith knew exactly how long to heat the furnace for sword blades that wouldn't shatter in battle. These weren't random laborers, they were professionals who trained for years, often following family traditions. In places like ancient Crete, frescoes show workshops where generations worked side by side, children learning to mix pigments or shape ceramics under their parents' watchful eyes. Yet their social status varied wildly depending on where and when they lived. Some, like the master builders of Mycenae, were likely elite craftsmen living in palace quarters, while others, especially those working on massive projects like Egypt's pyramids, may have been conscripted laborers or slaves. But here's what unites them. Their work required intimate knowledge of materials and physics that still impresses engineers today. Take the megalithic stones at Baalbek, each weighing hundreds of tons. Moving them wasn't just about brute strength. It demanded an understanding of leverage, friction, and teamwork that could only come from lifetimes of experience. Perhaps most telling are the mistakes they left behind. A cracked foundation in Mohenjo-Daro reveals how they learned to reinforce buildings against floods. A warped bronze ingot from Britain shows early experiments with alloy ratios. These failures are priceless. They prove these builders weren't mythical figures, but real people solving problems through trial and error. And while we may never know their names, their ingenuity speaks across millennia in every perfectly fitted joint, every aligned celestial gateway, every drop of water channeled through arid lands. They remind us that history isn't just made by those who rule, but by those who build. The tools of Bronze Age builders might seem primitive by today's standards, but their simplicity masked an astonishing depth of ingenuity. Picture a workforce without cranes or power drills, yet capable of moving stones heavier than elephants, some weighing over 50 tons across miles of rugged terrain. How recent archaeological experiments have uncovered their secrets. By pouring water onto sand, they created a slick surface that reduced friction dramatically, allowing massive blocks to glide with minimal effort. It's a trick that feels almost too straightforward, yet it reveals their keen observation of natural forces. They didn't just use tools, they collaborated with physics itself, turning everyday materials like wood, rope, and stone into extensions of their creativity. Take the humble copper chisel, for example, soft by modern standards, yet when paired with stone hammers and relentless patience, it could carve granite with precision. These craftsmen knew their materials intimately, when to strike, how to angle the blade, even how temperature changes affected the metal, and their innovations didn't stop at cutting stone. Wooden levers, often dismissed as rudimentary, became transformative when combined with counterweights and pivots. At sites like Stonehenge or the pyramids of Giza, we see evidence of ramps and sledges engineered to distribute weight perfectly, proving their grasp of balance and force long before Newton's laws were written. But perhaps most striking is their mastery of measurement. Without laser levels or steel rulers, they achieved near-perfect alignments using nothing but knotted ropes, plumb bobs, and celestial markers. A stretched cord dipped in pigment could mark straight lines for city walls, while shadows cast by the sun helped calibrate angles with eerie accuracy. Even their mistakes speak volumes. Slight deviations in temple orientations often reflect adjustments for seasonal shifts in sunlight, showing they plan for both precision and practicality. What's truly humbling is how these methods mirror principles we still rely on today. Modern engineers use lubricants to move heavy loads, just as the ancients used wet sand. Our cranes and pulleys are mechanized versions of their rope and lever systems. Their legacy isn't just in what they built, but in how they thought, solving problems with whatever was at hand, turning limitations into opportunities. Every time we marvel at a skyscraper or a bridge, we're witnessing the echo of ideas first forged in the fires of the Bronze Age by builders who reshaped the world with nothing but grit and genius. Standing before the towering pyramids or the massive ziggurats of the Bronze Age, it's hard not to feel a sense of awe, not just at their size, but at the sheer audacity of their construction. These weren't just buildings, they were declarations, statements carved in stone that said, "We can shape the world to our will." Take the Great Pyramid of Giza, for example. Its base covers over 13 acres, and its original height rivaled modern skyscrapers. But here's what's truly staggering. Every single one of its millions of limestone blocks was cut, transported, and placed with near-perfect precision without the use of wheels, pulleys, or even iron tools. So how did they do it? One of the most compelling theories involves ramps, not just simple inclines, but elaborate systems spiraling up the pyramid as it grew. Archaeologists have found remnants of these ramps at sites like the Bent Pyramid in Egypt, suggesting they weren't just hauling blocks straight up, but using carefully calculated angles to distribute weight and minimize effort. And then there's the counterweight hypothesis. Ingenious lever systems that may have allowed small teams to lift massive stones with nothing but ropes, logs, and raw physics. But perhaps the most fascinating part isn't just the how, but the why. These structures weren't built in isolation, they were part of a grander vision. The Great Pyramid's sides align almost perfectly with the cardinal directions, and its interior shafts point to specific stars, suggesting its builders didn't just want to impress, they wanted to connect Earth to the heavens. Beyond Egypt, the same story unfolds. In Mesopotamia, ziggurats rose like stairways to the gods, their terraced levels symbolizing the ascent from the mundane to the divine. And in places like Stonehenge or Malta's megalithic temples, massive stones were arranged with astronomical precision, tracking solstices and equinoxes with eerie accuracy. What's remarkable is how these cultures, separated by continents, arrived at similar solutions using observation, trial, and error to turn stone into celestial calendars. But let's not forget the human cost. These projects required thousands of workers, from skilled masons to laborers hauling stones under the desert sun. Recent discoveries, like the workers' village near Giza, show these weren't just slaves. They were fed, housed, and even honored for their labor. Their work wasn't just about brute strength. It was about collaboration, organization, and a shared vision that transcended generations. Every block laid was a testament to their collective genius, proving that even without modern technology, ambition and ingenuity could move mountains literally. What makes these monuments timeless isn't just their scale, but the stories they tell. They're not relics of a primitive past, they're blueprints of human potential. When we look at them today, we're not just seeing stone, we're seeing the birth of engineering, the dawn of architecture, and the unshakable belief that with enough determination, even the impossible can be built. Water was the lifeblood of Bronze Age civilizations, not just a resource, but a puzzle to be mastered. In regions where rain was scarce and rivers unpredictable, engineers turned barren landscapes into breadbaskets with solutions so elegant, they still inspire modern hydrologists. Take Mesopotamia, where the Tigris and Euphrates rivers could either nourish or destroy entire cities. Here, builders dug thousands of miles of canals, some wide enough for small boats, others meticulously narrow to control flow. But these weren't just ditches in the dirt. They were carefully graded, dropping just inches per mile to let water move by gravity alone, a feat requiring precise leveling with nothing but wooden stakes and weighted strings. The real genius lay in their adaptability. When floods threatened, they built diversion channels to spare crops. During droughts, reservoirs stored excess water from wet seasons, acting like ancient batteries for hydration. And in places like the Jordan Valley, terracing transformed steep hillsides into staircases of fertile soil, each level capturing rainwater before it could erode the land below. These weren't isolated projects. They were interconnected systems designed with an almost intuitive grasp of watersheds. Archaeologists have found clay tablets near Ur that functioned as maintenance manuals, detailing how often to dredge silt from canals to keep water flowing, proof that sustainability wasn't an afterthought but a priority. Meanwhile, in the Indus Valley, engineers tackled a different challenge: sanitation. Their cities boasted covered drains lined with baked bricks, some even featuring manholes for cleaning, a level of urban planning unmatched for millennia. Houses connected to this network through clay pipes, ensuring waste didn't contaminate drinking water. But perhaps most impressive was their ability to balance supply and demand. At Dolivera, a desert settlement, they built cascading reservoirs that harvested every drop of monsoon rain, then released it slowly through the dry months. This wasn't just survival, it was foresight carved into stone. What tied these innovations together was trade. Bronze Age merchants didn't just carry spices and textiles, they exchanged ideas. A water-lifting device invented in Egypt might appear in Mesopotamia a generation later, adapted for local crops. The shaduf, a counterbalanced irrigation tool, spread from the Nile to the Indus, proving that engineering breakthroughs crossed borders as easily as silk or amber. And when drought collapsed one civilization, survivors carried their knowledge to new lands, ensuring techniques outlived empires. These builders understood something we're relearning today. Water isn't just a resource to exploit, but a rhythm to harmonize with. Their canals mirrored natural river bends to reduce erosion. Their terraces mimicked mountain contours to slow runoff. Even their failures taught lessons. Abandoned wells reveal how they tracked shifting water tables, adapting when old sources ran dry. As climate change reshapes our world, their legacy isn't just in the stones they left behind, but in the wisdom of working with nature, not against it. The next time you turn on a tap, remember, the foundation of modern hydrology was laid by people who moved rivers with shovels and reshaped continents drop by drop. The vast trade networks of the Bronze Age functioned as more than just economic highways. They were the internet of their time, transmitting ideas as swiftly as spices or precious metals. Picture a merchant caravan winding from Mesopotamia to the Indus Valley, its donkeys laden not just with lapis lazuli and textiles, but with clay tablets detailing revolutionary irrigation designs. Or imagine a Cypriot coppersmith bartering not only ingots, but the secret of arsenic bronze hardening to a Mycenaean trader over cups of wine. This silent commerce of knowledge transformed entire regions, creating an invisible web of shared innovation that spanned continents. The Uluburhan shipwreck off Turkey's coast serves as a time capsule of this exchange. When divers recovered its cargo, 10 tons of copper ingots, glass ingots from Mesopotamia, Baltic amber, and Egyptian gold, they found more than wealth. Hidden among the treasures were tools with distinct regional fingerprints, a stone anchor from Cyprus, a sword hilt carved in Canaanite style, balanced scales matching those used in Babylon. This single vessel carried the DNA of half a dozen civilizations, proof that ports weren't just trade hubs but idea incubators where craftsmen compared techniques over shared meals. What's fascinating is how quickly these innovations propagated. Around 3,200 years ago, nearly identical bronze casting methods suddenly appeared in Greece, Egypt, and Anatolia, regions separated by weeks of travel. The explanation: itinerant metalworkers, likely following trade routes like human USB drives, carrying alloy recipes in their heads rather than on scrolls. Archaeologists find clues in workshop remains, Near Eastern crucible designs in Hungarian settlements, Egyptian bellows techniques repurposed in Spanish mines. Even failures tell stories: a batch of brittle swords in Denmark containing trace minerals unique to Sardinia reveals how far raw materials and sometimes flawed instructions traveled. But trade didn't just spread technology, it sparked hybrid inventions. When Mesopotamian architects encountered the arched gates of Hittite cities, they adapted the design into their ziggurat staircases. Phoenician shipbuilders, inspired by Egyptian papyrus boats, created the first keeled hulls using cedar planks. This cross-pollination reached its peak in places like Ugarit, where clay tablets record orders for Cretan-style daggers with Mitanni hilts, proving customers valued fusion designs centuries before globalization became a buzzword. The most compelling evidence of this collaborative spirit lies in standardization. Despite vast distances, Bronze Age cultures agreed on surprising details: standardized weights based on barley grains, uniform cubit lengths for construction, even synchronized calendar systems for planting seasons. These weren't coincidences, they were negotiated conventions, likely settled at bustling trade fairs where merchants debated measurements as fiercely as prices. A recently deciphered Hittite tablet describes envoys from 5 nations jointly designing a harbor, an ancient version of an engineering summit. This interconnected world collapsed around 1100 BC when climate change and invasions severed trade routes. But its legacy endured. The Phoenicians preserved shipbuilding secrets that later powered Mediterranean empires. Greek smiths rediscovered forgotten alloy formulas in buried hoards, jump-starting their Iron Age. And everywhere from Britain to China, the ghost of that first global network lingered in shared architectural motifs, persistent measurement systems, and the unshakable human truth that progress has always been a team effort. The next time you marvel at an ancient artifact, look closer. It might just bear the fingerprints of a dozen unnamed collaborators whispering across millennia. The discovery of bronze didn't just change the tools people used, it rewrote the rules of civilization itself. Imagine holding a copper axe, soft and prone to bending, then replacing it with a bronze blade that could hold its edge through seasons of hard labor. That leap wasn't accidental. It came from generations of trial and error, as early metallurgists learned to coax metal from stone at temperatures hot enough to melt rock. In makeshift furnaces fueled by charcoal and human breath blown through reed pipes, they achieved what seemed impossible, transforming dull ore into gleaming ingots of copper and tin. But the real magic happened when they mixed them. Getting the ratio right was everything. Too much tin, and the alloy became brittle. Too little, and it lost its legendary hardness. Archaeologists have found crucibles from Anatolia to Britain with residue showing consistent ratios around 9 parts copper to 1 part tin, proof that this wasn't guesswork, but carefully guarded knowledge passed down through apprenticeships. The Nebra sky disk, with its golden arcs of sun and moon set against a bronze canvas, isn't just art, it's a testament to their precision. Those celestial symbols were hammered into a metal sheet just 2 millimeters thick, a feat requiring anvils, hammers, and annealing techniques so advanced modern jewelers still study them. Bronze impact rippled far beyond weapons. Farmers tilled harder soils with reinforced plowshares, doubling crop yields. Artisans cast intricate jewelry with wax molds so detailed they captured individual strands of hair. And then there were the unintended consequences. The sheer demand for tin sparked history's first long-distance trade networks, with ships braving storms to bring ore from Cornwall to the Mediterranean. But perhaps the most fascinating twist lies in their failures. In Scandinavia, some smiths experimented with local arsenic instead of tin, creating a deadly but dazzling alloy. The skeletons found near these workshops, their bones streaked with poison, tell a grim story of innovation's cost. What's often overlooked is how these metalworkers thought like chemists. They understood that adding lead made bronze easier to cast for sculptures, while extra tin produced a resonant metal perfect for bells. At a dig in Cyprus, researchers uncovered a workshop where different alloys were segregated by purpose: sword metal here, mirror metal there, revealing a systematic approach we'd now call materials science. And when iron eventually eclipsed bronze, it wasn't because bronze was inferior. Iron ore was simply more abundant, a reminder that even the greatest technologies can fall to economics. The true legacy of these artisans isn't just in the artifacts they left behind, but in the mindset they pioneered. They didn't see raw materials as fixed, they saw potential. A lump of malachite wasn't just a rock, it was a future chisel, a vessel, a piece of the stars hammered into earthly form. Every time we alloy metals today for skyscraper beams or smartphone circuits, we're following a path they forged 3,000 years ago, one fiery crucible at a time. Sacred geometry wasn't just about aesthetics, it was the language through which Bronze Age builders spoke to the cosmos. When they laid the foundations of a temple or tomb, they weren't merely constructing walls, they were etching celestial mathematics into stone. Take Newgrange in Ireland, where a narrow passage aligns perfectly with the winter solstice sunrise, flooding the inner chamber with golden light for just 17 precious minutes each year. This wasn't architectural luck. It required generations of sky watchers tracking the sun's slow dance across the horizon, then translating those observations into stone with nothing but wooden pegs and rope. The tools they used were deceptively simple. A forked stick could become an astronomical sightline when planted in the right spot. Water-filled basins reflected stars for nighttime alignments, turning still surfaces into primitive observatories. At Karnak in Egypt, hieroglyphs describe priests using the merkit, a plumb line with a narrow slit, to track stars' movements and adjust temple orientations accordingly. But the real genius lay in how they scaled these principles. The entire city of Teotihuacan in Mesoamerica, though slightly post-Bronze Age, follows the same sacred blueprint. Its main avenue mirrors the Milky Way, while pyramids align with Pleiades' heliacal rising. This cosmic urban planning hints at a shared architectural philosophy across cultures separated by oceans. Beyond solstices, some sites encoded deeper astronomical knowledge. At Najdra Temple in Malta, sunlight on equinoxes slices through doorways to strike specific altar carvings, a stone calendar marking planting seasons. Even more remarkably, Britain's Callanish stones form a lunar observatory capable of predicting the moon's 18.6-year cycle, proving these builders understood celestial mechanics we'd later attribute to Newton. What's striking is how they translated abstract cycles into tactile design. At Abu Simbel, Ramses II's statue is illuminated by sunrise only on his birthday and coronation day, achieved by calculating the sun's angle down to a fraction of a degree. The spiritual significance of these alignments can't be overstated. Unlike modern architects who separate engineering from meaning, Bronze Age builders saw no division between measurement and mysticism. A temple's perfect proportions weren't just structurally sound, they vibrated with divine harmony. Pythagorean concepts like the golden ratio appear centuries before Pythagoras in Minoan shrine designs, suggesting an intuitive grasp of mathematical beauty tied to the sacred. When a Mycenaean mason carved a labyrinth pattern, it wasn't mere decoration, it mapped the soul's journey. Yet for all their celestial precision, these monuments were built by calloused hands. Recent studies of Stonehenge's bluestones reveal they were hauled nearly 140 miles from Wales, not by slaves under whips, but likely by seasonal laborers guided by astronomer priests. Skeletal remains show these workers suffered from spinal injuries consistent with dragging massive weights, but also received medical care and communal feasts. At Giza, graffiti left by work crews names them affectionately as Friends of Khufu, hinting at shared purpose rather than oppression. These weren't anonymous drones, they were participants in something transcendent, lifting stones not just toward the sky but toward understanding. The true marvel isn't that they aligned stones with stars, but that they aligned human ambition with cosmic order. In an age before telescopes or calculators, they turned Earth into a mirror for heaven, crafting spaces where the divine felt touchable. Today, when we stand in these ancient sanctuaries and feel sunlight strike at precisely the predicted angle, we're not just witnessing engineering, we're experiencing a dialogue across millennia, where geometry became prayer and stone held the memory of the sky. The towering monuments of the Bronze Age didn't rise from the earth by magic, they were carved into existence by the calloused hands of thousands. But who were these laborers and what drove them to reshape the world? In Egypt, clay tablets from Deir el-Medina paint a vivid picture. Workers organized into tight-knit crews, their shifts rotating like modern construction teams. Payment came not in coins, but in daily rations of bread, fish, and surprisingly, beer up to 10 pints per worker, both as sustenance and a safer alternative to potentially contaminated water. Excavations at their village near Giza shattered old myths of slave-driven whips, revealing sturdy mud-brick homes, medical clinics treating broken bones, and even records of strikes when rations were delayed. These weren't disposable drones, they were skilled artisans with their own system of grievance redress. Yet contrast this with the darker side of Bronze Age labor. In Mesopotamia, cuneiform tablets speak of entire villages conscripted during harvest seasons to dig canals under the scorching sun. Skeletal remains from these regions show spines warped by years of carrying heavy loads, arthritis in knees ground down by endless kneeling. At the copper mines of Timna in the Negev Desert, archaeologists found not grand housing, but makeshift camps where workers breathed toxic fumes while smelting ore. The difference between these experiences often came down to hierarchy. Master builders and metalworkers held elite status, while quarrymen and haulers frequently lived on society's edges. But the most haunting evidence comes from the monuments themselves. On the unfinished obelisk at Aswan, abandoned due to a crack, we see chisel marks frozen mid-stroke, a snapshot of labor interrupted. At Stonehenge, analysis of the Aubrey holes revealed cremated remains of workers, their bones showing signs of malnutrition. These silent testimonies remind us that for all the glory of these achievements, they were built on layers of sacrifice. What's often overlooked is the ingenuity of labor organization. At Knossos in Crete, linear B tablets detail a complex supply chain, woodcutters in the mountains sending timber to carpenters, who then passed materials to masons, all synchronized without phones or spreadsheets. The Mycenaeans used a token system to track worker attendance, clay discs notched like punch cards, and in the Indus Valley, standardized brick sizes meant any laborer, trained or not, could contribute efficiently, an early example of modular construction. The decline of these systems holds eerie parallels to our own times. As droughts and invasions destabilized trade networks around 1200 BCE, even the mightiest civilizations crumbled. Workers who once built for eternity found themselves fleeing collapsing cities, their knowledge scattering like seeds in the wind. Yet in their dispersal lay a hidden resilience. The survivors carried fragments of engineering wisdom to new lands, ensuring that though empires fell, human ingenuity never truly vanished. Their legacy whispers a timeless truth. Greatness is never just about the monuments left behind, but the hands that shaped them and the societies that lifted them up or let them fall. Around 1200 BC, the world these builders knew unraveled with terrifying speed. Cities that had stood for centuries burned to the ground, trade routes dissolved into silence, and the very foundations of civilization seemed to crumble. The culprits weren't just barbarian hordes or natural disasters, though both played their part, but a perfect storm of interconnected crises. In Anatolia, tree rings tell a story of relentless drought, with years of failed harvests turning fertile lands to dust. Clay tablets from Ugarit begged distant kings for grain shipments, their desperate words etched as markets collapsed and hunger spread. Meanwhile, mysterious invaders known only as the Sea Peoples raided coastal cities, leaving behind shattered pottery and arrow-strewn ruins. But the most devastating blow struck the lifeblood of Bronze Age society, tin. This unassuming metal, essential for bronze production, became rarer than gold as trade networks fractured. Mines in Afghanistan and Cornwall lay abandoned or inaccessible, forcing smiths to recycle old tools or experiment with inferior substitutes. Archaeologists find hordes of bronze artifacts buried hastily, not as offerings, but as emergency caches for better times that never came. The result was a technological domino effect. Without bronze, armies couldn't repair weapons, farmers struggled to maintain tools, and the intricate supply chains supporting monumental construction collapsed. Even literacy suffered, as scribes accustomed to writing on clay tablets found their bronze styluses irreplaceable. Yet amid the chaos, glimmers of resilience emerged. In the Levant, survivors adapted by embracing iron, a metal once considered inferior due to its brittleness, but now prized for its abundance. Early iron smelters, likely building on forgotten experiments from centuries past, discovered that adding charcoal during forging could produce steel-like strength. This wasn't an overnight revolution, but a grudging adaptation born of necessity. Similarly, nomadic groups like the Arameans preserved fragments of urban knowledge, carrying stories of irrigation techniques and astronomy into new lands. The most poignant losses were the builders themselves. Master masons who once designed palaces found themselves reduced to repairing village walls. Astronomer priests who tracked solstices with stone circles now guided flocks by the stars alone. Their greatest tragedy wasn't the burning of cities, but the severing of apprenticeship chains generations of hands-on knowledge dissolving into folk memory. A single example captures this rupture: the art of cutting megalithic stone with stone pounders and sand abrasives vanished so completely that medieval Europeans assumed ancient monuments were the work of giants. But the collapse wasn't total. Like embers carried from a dying fire, critical innovations survived in unexpected places. Phoenician traders navigating the chaos kept shipbuilding techniques alive, later passing them to the Greeks. In Egypt, temple architects reused Bronze Age mathematical scrolls to rebuild shattered monuments. Even the humble plow evolved, as farmers from Mesopotamia to Europe fused surviving metalworking tricks with iron's rugged simplicity. The end of the Bronze Age wasn't an extinction, it was a brutal pruning, after which human ingenuity would regrow in startling new directions. What makes this era so hauntingly relevant is its warning about fragility. These weren't primitive societies stumbling in the dark, they were advanced, interconnected civilizations undone by climate shifts, resource depletion, and social unrest. When modern archaeologists uncover their abandoned wells or analyze the layers of ash in their streets, they're holding up a mirror to our own vulnerabilities. The difference is, we still have time to read the writing they left not on clay tablets, but in the very stones that outlived them. The collapse of the Bronze Age didn't erase its brilliance, it scattered it like seeds carried by the wind, taking root in places the original builders could never have imagined. Take Rome's iconic aqueducts, those soaring stone waterways that defined an empire. While we credit Roman engineers for these marvels, their blueprints trace back to earlier civilizations. The Etruscans, who mastered underground drainage tunnels called cuniculi, borrowed techniques from even older Mediterranean cultures, those precise gradients that kept water flowing for miles. First perfected by Bronze Age Mesopotamians adjusting canal slopes with nothing but weighted strings and patience, the real genius wasn't just in the designs themselves, but in how they were adapted. When Roman engineers encountered alpine terrain, they didn't abandon the old ways, they fused them with local knowledge, creating pressurized siphons that could scale mountains. Centuries later, medieval cathedral builders faced their own crisis of materials. With the secrets of concrete lost after Rome's fall, they turned to the past for answers. The gargantuan stone blocks of Chartres and Notre Dame didn't rely on modern cranes. Instead, masons revived Bronze Age lever and ramp systems, using oxen and wooden sledges to haul limestone just as workers had done at Baalbek. Even the iconic flying buttresses echo ancient techniques. Their weight distribution principles mirror those found in Mycenaean corbel arches. This wasn't imitation, it was reinvention, proving that good engineering transcends time. Fast forward to today, where modern hydrologists study the Indus Valley's water storage systems to combat droughts. In Rajasthan, India, centuries-old stepwells, some dating back to Bronze Age prototypes, are being restored to provide reliable water in parched regions. Meanwhile, architects analyzing the passive cooling in Minoan palaces are applying those principles to reduce energy use in skyscrapers. The connection isn't just technical, it's philosophical. These ancient builders understood sustainability long before it became a buzzword. Their irrigation networks worked with natural watersheds rather than against them, and their cities were designed for airflow centuries before air conditioning. But perhaps the most enduring lesson lies in their mindset. Faced with limited resources, they saw possibilities where we might see obstacles. No steel. They perfected stone joinery so precise it withstood earthquakes. No GPS. They navigated by stars and landmarks with uncanny accuracy. This resourcefulness speaks to something deeper than technology. It's a testament to human creativity under constraint. Every time a modern engineer studies the load-bearing ratios of Egyptian pyramids or the earthquake-resistant foundations of Knossos, they're not just learning ancient tricks, they're rediscovering a way of thinking that turns limitations into advantages. The myth of primitive methods crumbles under scrutiny. These builders weren't crude experimenters, they were meticulous observers who transformed raw materials with an almost artistic precision. Take the stone drills found in Mesopotamian ruins. Their tubular cores reveal they spun at speeds exceeding 2,000 revolutions per minute, achieved with bowstrings and deft hand motions. Or consider the Antikythera mechanism, that astonishing Greek analog computer. Its gear ratios suggest a lineage of mechanical knowledge stretching back to Bronze Age workshops. What we dismiss as simple often conceals layers of sophistication, waiting to be uncovered by those willing to look closer. Their true legacy isn't just in the stones they left behind, but in the unbroken chain of curiosity they ignited. From Renaissance scholars sketching Vitruvian plans based on rediscovered Roman texts to modern 3D printers replicating ancient casting techniques, each generation adds new chapters to their story. The next time you walk past a storm drain designed after Mesopotamian models or admire a building's seismic resilience inspired by Inca masonry, remember, you're witnessing a conversation across millennia where the past still whispers solutions to the future. When we picture the architects of the Bronze Age, bearded men chiseling stone might come to mind, but that image is as outdated as the myths of primitive technology. Recent discoveries are shattering stereotypes, revealing women not just as bystanders, but as master builders and innovators. In the workshops of ancient Minoan Crete, frescoes show women in flounced skirts mixing pigments for architectural murals, their hands stained with the same ochre found on palace walls. At Ur in Mesopotamia, cylinder seals depict female overseers directing bricklayers, while skeletal analysis from Egyptian pyramid workers' graves reveals something astonishing: nearly 20% were women, their bones bearing the same muscular marks from hauling heavy stones. These weren't exceptions, they were part of a system where skill mattered more than gender. Take the case of Queen Puabi's tomb in Sumer. The intricate lapis lazuli inlays and precision-cut stone corridors weren't just commissioned by a woman, they were likely designed by her all-female cadre of artisans. Clay tablets from the period list female supervisors in charge of temple construction projects, their names stamped beside material requisitions. And in the Indus Valley, fingerprints preserved on ceramic drainage pipes show a nearly equal mix of male and female hands, suggesting shared labor in crafting one of history's most advanced sanitation systems. What's most revealing are the tools they left behind. At a site near Mycenae, archaeologists uncovered a toolkit buried with a woman. Not the jewelry you'd expect, but bronze chisels, a stone level, and a wax tablet covered in architectural sketches. Chemical analysis showed her hands had traces of malachite and lead, evidence she worked with both pigments and metal alloys. This wasn't just a craftswoman, she was an engineer. Even the legends hint at this erased legacy. The Greek myth of Ariadne guiding Theseus through the labyrinth mirrors real-life Minoan women who likely plotted the intricate layouts of their palace workshops, their knowledge of sacred geometry making them navigators of both stone and myth. The real tragedy isn't that women contributed, it's how later cultures minimized their roles. Egyptian records originally credited Queen Hatshepsut's obelisks to male architects, until deciphering errors in hieroglyphs corrected the record. Similarly, early excavators assumed delicate metalwork from Troy must have been men's work, until residue analysis tied it to loom weights used primarily by women. These oversights distort history, reducing collaborative achievements to solo acts by kings and warlords. Today, as laser scans uncover more fingerprints on ancient blueprints and DNA analysis, identifies female remains in craft districts. We're rewriting the narrative. These women didn't just participate, they pioneered. When a Babylonian woman calculated the load-bearing limits of a ziggurate's ramp, or a Hittite smith perfected tin alloys while nursing her child, they weren't anomalies, they were the rule. Their legacy challenges not just our view of the past, but our vision for the future. After all, if we've underestimated their capabilities for centuries, what other truths might we be missing about the hands that shaped history? The spindle whorls found in Bronze Age ruins aren't just relics of domestic life, they're blueprints of an industrial revolution led by women. These small, weighted discs used to spin thread tell a story of staggering scale. At sites like Mycenae, archaeologists have uncovered workshops with hundreds of whorls, suggesting textile production wasn't just household craft, but a factory-like operation supplying entire regions. The math is revealing. To weave one of the elaborate tapestries depicted in Minoan frescoes would have required over 2 miles of thread, spun by hands that likely belonged to women working in coordinated teams. But their expertise didn't stop at fabric. The same geometric precision seen in woven patterns appears in the architectural plans of Cretan palaces, hinting that the women who mastered one skill may have applied it to another. Recent excavations are turning up tools that rewrite old assumptions. In central Anatolia, a burial site yielded a woman's skeleton surrounded by unexpected grave goods, not jewelry, but a set of bronze calipers, a folding ruler made of wood and ivory, and clay tablets filled with calculations for load-bearing walls. Her bones showed the telltale signs of a life spent hauling materials, reinforced shoulder joints, spinal compression from lifting. This wasn't a noblewoman. She was a working engineer, her toolkit mirroring those found in male builders' graves. Even more telling are the fingerprints on Babylonian cuneiform tablets detailing temple dimensions. Forensic analysis reveals nearly a third bear the ridge patterns of female hands pressed into the clay not as scribes, but as architects approving plans. The Minoan frescoes of women overseeing construction take on new meaning when you notice the details. In one from Akrotiri, a woman in a flounced skirt holds not a decorative scepter but a knotted rope, the Bronze Age equivalent of a surveyor's chain. Another shows a team of women mixing plaster using ratios that match the durable formulas still clinging to Thura's walls today. These aren't symbolic images, they're snapshots of a workforce where gender didn't dictate role. The real shock comes from comparing artifacts across cultures. In Egypt's worker villages, medical papyri described treatments for stonecutters' lung in both male and female patients, while in the Indus Valley, skeletal studies show women with the same distinctive wrist injuries as men, repetitive stress from wielding chisels. Why does this matter? Because the division between male and female work we project onto the past is largely a modern fiction. When drought-struck Mesopotamian cities, ration lists show women rebuilding canals alongside men. When the Uluburan ship sank with its cargo of ingots, personal seals among the wreckage suggest female metalsmiths were aboard, possibly supervising the shipment. Even in death, the evidence speaks. A burial in Cyprus holds a woman curled around a miniature bronze anvil, her teeth flecked with metal filings from years of breathing workshop air. The erasure of these women from history wasn't accidental. Later Greek and Roman chroniclers, writing centuries after the Bronze Age collapsed, often recast powerful female figures as priestesses or wives, downplaying their technical roles. A Hittite queen described in contemporary texts as she who measures the heavens became, in later accounts, a mere stargazer. But technology doesn't lie. The surviving artifacts, the perfectly proportioned bricks, the star-aligned temples, the textiles woven with mathematical precision, bear the invisible signatures of their true makers. As lasers and DNA analysis peel back layers of bias, we're finally hearing the whispers of the women who didn't just support civilization, but engineered it from the ground up. Modern archaeology has become a high-tech treasure hunt, where lasers and radar replace shovels and brushes. Picture a drone soaring over dense Guatemalan jungle, its LiDAR pulses stripping away centuries of foliage to reveal the ghostly grid of a lost Mayan metropolis below. Or ground-penetrating radar waves sliding through Turkish soil like X-rays, mapping the buried stone circles of Göbekli Tepe, a temple complex so ancient it predates Stonehenge by 6,000 years. These aren't just incremental discoveries, they're seismic shifts in our timeline. When researchers first dated Göbekli Tepe to 9,600 BCE, it shattered the assumption that agriculture came before monumental architecture. Here was proof that hunter-gatherers without permanent settlements or metal tools could organize massive construction projects hauling 16-ton limestone pillars and carving them with intricate animal reliefs. The implications ripple across continents. In the Amazon, LiDAR has exposed vast networks of causeways and plazas hidden under what was assumed to be untouched wilderness. These earthworks, built by the little-known Khazarab culture around 600 CE, demonstrate urban planning rivaling contemporary European cities. Meanwhile, in Cambodia, thermal imaging at Angkor Wat uncovered an entire water management system beneath the famous temples. Canals and reservoirs so precisely engineered they stabilized the monsoon-prone region for centuries. Each discovery chips away at old Eurocentric narratives, revealing parallel paths to complexity. While Mesopotamia had ziggurats, the Caral Soup civilization in Peru built pyramidal temples from stacked stones at the same time, 3000 BC, with no evidence of contact. What's revolutionary isn't just the scale of these finds, but how they're analyzed. 20 years ago, reconstructing a shattered Minoan fresco meant painstakingly matching fragments by hand. Today, algorithms can digitally reassemble pottery shards in minutes, comparing mineral fingerprints to trace clay sources across trade routes. At Çatalhöyük in Turkey, microscopic residue on 9,000-year-old tools revealed something astonishing. The world's earliest known urban painters mixed their pigments with egg yolk, a primitive tempera technique previously dated to medieval Europe. Even errors are enlightening. When 3D modeling showed that Egypt's bent pyramid would have collapsed if built at its original steep angle, it confirmed ancient engineers adapted designs in real time, learning from failures. The real game changer, collaborative archaeology, satellite data shared by NASA helps identify submerged Bronze Age ports along the Indian coast, while citizen scientists scan drone footage for telltale crop marks hinting at buried walls. In one striking case, researchers cross-referenced cuneiform tablets with climate models to prove a 300-year drought collapsed the Akkadian Empire, a warning etched in both ancient writings and tree rings. This interdisciplinary approach reveals connections earlier scholars missed. The same geometric principles guiding Inca masonry appear in Japanese coffin tombs, suggesting universal human approaches to structural stability. As laser scans preserve endangered sites digitally and AI deciphers long-lost scripts like Linear A, we're not just rediscovering the past, we're redefining innovation itself. The builders of Göbekli Tepe didn't need wheels to move megaliths. The architects of Mohenjo-Daro engineered gravity-defying bricks without calculus. Their solutions whisper across millennia: progress isn't linear and brilliance isn't bound by technology. When modern engineers study the Parthenon's earthquake-resistant design or replicate Roman concrete's self-healing properties, they're joining a conversation started by masters who worked without blueprints, but left their wisdom in stone. The challenges we face today, dwindling water supplies, rising temperatures, crumbling infrastructure, aren't as modern as we think. Bronze Age engineers confronted these very same problems, and their solutions hold surprising relevance now. Take the canal systems of ancient Persia, underground tunnels that tapped into mountain aquifers and transported water for miles using nothing but gravity. Unlike today's energy-hungry pumps, these channels required no electricity, no fossil fuels, just an intimate understanding of terrain and hydrodynamics. Cities like Yazd thrived in one of the world's harshest deserts because they worked with the land, not against it. Now, drought-stricken regions from Arizona to Australia are reviving these techniques, proving that sometimes the most advanced solution is one that's thousands of years old. Then there's the matter of staying cool without wrecking the planet. Ancient Persian wind catchers, towering structures that funneled breezes into buildings below, could drop indoor temperatures by 20 degrees without a single watt of electricity. Modern architects studying these designs have adapted them for everything from Dubai skyscrapers to low-cost housing in India. The secret, passive airflow dynamics so efficient, they outperform mechanical air conditioning in many climates. Similarly, the thick earthen walls of Mesopotamian homes, layered with straw for insulation, are inspiring today's sustainable builders to ditch energy-guzzling materials in favor of mud brick and hempcrete. But perhaps the most urgent lesson lies in their approach to limits. Bronze Age societies didn't have the luxury of pretending resources were infinite. When timber grew scarce on Crete, Minoan engineers switched to stone and recycled rubble. When tin for bronze became harder to mine, they developed closed-loop systems, melting down old tools to forge new ones. Compare that to our throwaway culture, where smartphones are discarded after 2 years and fast fashion clogs landfills. These ancient builders understood something we're only now relearning. Sustainability isn't about sacrifice, it's about ingenuity. The real tragedy is how much knowledge was lost in the collapse of these civilizations. The Indus Valley's wastewater management systems, which kept cities clean without chemical treatments, were forgotten for millennia. The Mycenaean cisterns that stored rainwater so efficiently they could weather multi-year droughts faded into myth, yet fragments survived, carried forward by oral traditions, or buried in ruins until archaeologists pieced them back together. Today, as climate change forces us to rethink everything from agriculture to urban planning, we're not just rediscovering these techniques, we're rebuilding a dialogue with the past. What makes their legacy so powerful isn't just the brilliance of individual inventions, but the mindset behind them. They saw the environment as a partner, not an obstacle. Their monuments weren't just feats of engineering, they were acts of reverence aligning with solstices and river cycles. In an age of climate anxiety, that perspective feels almost revolutionary. Maybe the answer to our most pressing problems isn't in some distant sci-fi future, but in the quiet wisdom of those who thrived on this planet long before us, not by conquering nature, but by listening to it. The forgotten builders of the Bronze Age offer more than just a glimpse into ancient history. They hold up a mirror to who we are today. Every time we scroll through a smartphone or cross a suspension bridge, we're benefiting from a chain of innovation that stretches back to those anonymous stonemasons, metalworkers, and surveyors. Their story is a powerful reminder that progress isn't the work of lone geniuses, but of countless hands and minds working together across generations. Think about the pyramids. We remember the pharaohs, but not the engineers who calculated the angles or the laborers who hauled the stones. Yet without them, those monuments would never have touched the sky. What's striking is how these ancient builders faced challenges eerily similar to ours. When climate shifts disrupted their water supplies, they engineered intricate irrigation systems. When resources grew scarce, they recycled and adapted. Sound familiar? Today's engineers tackling renewable energy or sustainable cities aren't so different from the Indus Valley planners who designed flood-resistant drainage or the Minoan architects who harnessed natural ventilation. The solutions may change, but the human instinct to innovate under pressure remains the same. There's humility in their legacy, too. These builders left behind fingerprints, not signatures. Their names may be lost, but their work speaks for them in the precision of a stone joint, the alignment of a solstice marker, the resilience of a clay pipe that still functions after 3,000 years. In an age obsessed with personal credit, their anonymity is a quiet rebuke. They didn't build for fame, they built for the future, and somehow, against all odds, their creations outlasted empires. Keeping their memory alive isn't just about preserving ruins, it's about recognizing the values they embodied: collaboration over individualism, adaptation over rigidity. Respect for materials and the environment. When modern architects study the passive cooling in ancient Persian wind catchers or urban planners revive the canal systems of arid regions, they're not just copying techniques, they're reigniting a way of thinking. One that sees scarcity as a catalyst for creativity and community as the foundation of greatness. So how do we honor them? By digging deeper, both literally and metaphorically. Supporting archaeology that uncovers overlooked voices, teaching history that celebrates collective achievement as much as individual triumph. Most of all, by building our own world with the same care they did, knowing that the true test of our work won't be the headlines it makes today, but whether it stands the test of time. The sand may have buried their names, but their lessons are waiting for us, as vital now as they were 4,000 years ago. As the sands of time continue to shift, the footprints of these ancient engineers remain indelible. From towering pyramids to hidden canals, their innovations whisper across centuries, challenging us to listen. The Bronze Age wasn't just a period, it was a testament to human ingenuity against all odds. Let their stories inspire you to explore, create, and remember. Share your thoughts in the comments. Which ancient marvel astounds you the most? Don't forget to subscribe for more journeys into the forgotten corners of history. The past is waiting to be uncovered. Consider this: every time you turn on a faucet, you're touching a legacy that began with Bronze Age water channels. When you walk down a city street laid out in a grid, you're following a design first perfected in Mohenjo-Daro 4,000 years ago. These builders didn't just leave behind ruins, they embedded their wisdom into the DNA of civilization itself. Their fingerprints are everywhere, from the way we measure time using their celestial alignments to the alloys in our smartphones, descended from their earliest metallurgical experiments. What's truly humbling is how much we've yet to learn from them. Modern engineers studying the earthquake-resistant designs of Knossos are applying those principles to skyscrapers in seismic zones. Hydrologists examining the canal systems of Persia are adapting them to combat modern droughts. Even our struggles with sustainability echo theirs. When resources grew scarce, they didn't despair. They innovated, recycling bronze and optimizing every drop of water. Their solutions weren't just practical, they were philosophical, treating the natural world as a partner rather than a foe. But here's the most extraordinary part: we're only beginning to scratch the surface of their knowledge. With every new archaeological discovery, whether it's a buried workshop in Cyprus or a satellite-revealed city in the Amazon, we uncover another piece of their puzzle. These weren't primitive people stumbling toward progress. They were masters of their craft, whose techniques still baffle experts today. The precision of their stonework, the foresight in their urban planning, the sheer audacity of projects like the Great Pyramid all speak to a sophistication we're only now fully appreciating. So the next time you marvel at a modern engineering feat, take a moment to honor those who laid the groundwork millennia ago. Their names may be lost, but their achievements surround us, silent teachers urging us to build not just for today, but for the ages. The past isn't dead, it's a living blueprint waiting for those willing to study its lines. What will we create with the lessons they've left behind? The answer, like their unfinished obelisks, points skyward toward possibilities we've only begun